this assessment asks us to draw a reaction coordinate diagram for a figure from the textbook. That figure is shown here on screen. Now, this reaction is the formation of an ester from an alkene and a carboxylic acid. If we look at the reaction over here and describe it in terms of its steps, we're going to protonate the alkene, that's step 1. The carboxylic acid will attack as a nucleophile, that's step 2. And then a proton will be removed, that's step 3. And so our reaction coordinate diagram is going to have 3 hills. Based on the fact that it has 3 steps, we know that it will have 3 hills. And so then the question for us is, how do we orient the energy of those hills? Well, protonating the alkene, we go from a neutral alkene to a tertiary carbocation. That's probably going to be a slightly uphill step, so we can kind of abbreviate this as the alkene here to make this carbocation. Again, just making sure that we label these steps. It's probably uphill in that case. At this point, the nucleophile will attack that carbocation. That's probably going to be a downhill step. Maybe we'll have it finish around there, not bringing it all the way, but this would be the molecule that would have this form where we've got this carbocation, again, just using this as an abbreviation of that. And then in the last step, that proton is removed, and that probably represents the step where this becomes an overall favorable process. So bringing it down to here, and we'll label this as what is probably the ester product. That is the product of these reactions. Now, when the second part of this question asks us which is the rate determining step, it's going to be the step that has the highest activation energy, and so that is step 1. Protonating the alkene is probably the slow and therefore the rate determining step in this reaction.